Hello, ladies and gentlemen. Today you are going to be taking your first quiz on prisms and cylinders. You may use your formula sheet, and you're going to have to write down your calculations just as we've practiced in class. This quiz has 5 questions on it, all right? I'm going to say that each question should take you somewhere between, I'd say, 5 and 8 minutes, all righty? I think closer to 5, but we're building in a few extra minutes. Just to check your work. So I do believe that this quiz should be done in about 40 minutes, all right, although you will have the remainder of the period. Okay, so you need to make a decision and figure out if you're going to write on the PDF that is posted on Google Classroom in the classwork section, or if you're going to write it on the paper form and take pictures in the end. All right, so I'm going to start reading the directions, and here we go. For this quiz, be sure to write down all calculations. You may write on the PDF digitally using your iPad, or you may use the paper form. PDFs can be found in the classwork section on Google Classroom titled Unit 9, Part 1, Quiz, Edpuzzle for Prisms and Cylinders. You can save your progress and submit digitally the way we have all year. Guys, however, though, if you use paper form, all right, you got to take pictures of each page and submit them in the same place. They're going in Google Classroom. We'll show you at the end. Regardless, you will need to submit your writing on Google Classroom for proof that you are doing the work as we go along. As you proceed through the video, guys, if you make any mistakes, you should fix any mistakes that you make, and because you want to be successful for the questions that follow. All right, without further ado, here we go. So what I'd like to do is I want to start with question number 1. All right, now you're going to submit your answers through the video as we go along. While you're while you're working on certain questions, write your answers down on the quiz that you're going to turn in later on. Alrighty, so here we go. Number 1, use the diagram at the right to find the desired information below. Part A, here we go, guys. First question. Classify the solid and be specific. This solid is an oblique pentagonal prism. It is oblique because the bases are not perpendicular to one another. The sides are not rectangles. It's pentagonal because each of the bases are congruent 5-sided polygons, and it's a prism because it has 2 bases. All right, next question. How many vertices does the solid have? This prism has 10 vertices. As you can see at the right, I have used green dots to indicate all of the 10 corners. Next question, how many lateral edges does the solid have? Okay, based on the diagram at the right, I've highlighted the lateral edges with blue. There are 5 lateral edges. Next question, which of the following is a lateral face? Okay, there are 5 lateral faces. Each of them are on the sides, right? Lateral faces connect the bases. So what I'm going to say here is the lateral face, JEDI, is the lateral face we should have picked. Alrighty? So, next question. Which formula would you use to find the lateral area of the solid? Okay, so all you have to do is really go to your formula sheet, right, which you're going to need during this quiz, and find that the lateral area of any prism will be found by using LA equals PH, perimeter of the base times the height. Okay, question number 2. Number 2 is going to be asking us to really use our formulas. So it says for the directions, a right cylinder has a volume of 100 pi cubic yards, or yards cubed, and a height of 4 yards. Use this information to find the values below. Leave all answers in exact form. All right, guys, so there's no decimals or rounding. We're leaving it exact in terms of pi. Part A, based on the information above, find the radius of this cylinder. Okay, so after we read the directions, they mention to us that we are given the volume. So guys, right over here, I'm going to make my checklist that the volume was 100 pi. They also gave us the height of the cylinder is 4. So as soon as I go to my formula sheet, I know that I'm going to use the volume formula. V equals pi r squared h. I'm now going to substitute the volume and the height, and then the only variable left is going to be my radius. Okay, now, after zooming in a little bit, originally we had 100 pi equals pi r squared times 4. Now, I just thought, you know what? Sure, I could divide out the pies in the first step. I could divide out the pies, 4 in the second step. But listen, why don't I just divide by 4 pi, and then I can clear out my 4s and my pies in one shot, okay? What I do to one side, I do to the other, and then that's going to leave us with r squared equals 25. All right, so our radius turns out to be 5 yards. Okay, so now we still know that the volume is 100 pi, the height is 4, and now we know the radius is 5 yards. Next question, find the lateral area of the cylinder. Okay, the lateral area for this cylinder is going to be 40 pi yards squared. All right, once again, boys and girls, we go to our formula sheet, we find the formula that we should be using. In this case, lateral area of a cylinder is 2 pi RH. So all I'm going to do is just substitute 5 for radius, 4 for height, and there is the area for the walls of our cylinder, right? AKA the lateral area. Okay, finally, we come to part C to find the surface area of the cylinder. Okay, we are going to get a surface area of 90 pi yards squared. If I haven't stressed it enough this year, guys, I don't know if you've been paying attention. Write your formulas always. Formula, substitution, and then answer with a label. All right, so in this case, we had already found the lateral area, 2 pi RH, from the previous question. So I didn't redo that. I just wrote that down as 40 pi. And then, guys, we're going to have 2 capital B's, 2 base areas, or 2 times pi r squared, which will give us 50 pi, or a total of 90 pi yards squared. Okay, that brings us to question number 3. So in this case here, the directions say the solid at the right is a right regular pentagonal prism. The prism is 40 centimeters tall, and each base has a perimeter of 55 centimeters. Use this information to find the values below. So part A, find the area of one base. Okay, we need to use a little trigonometry for this one. Our base area for one of them turns out to be roughly 302.8 yards squared. Now, depending on how you rounded, we should be pretty close to this. All right, so first and foremost, I'd like to direct your attention down here to how we should have split up the pentagon, and then we should have used a tangent equation to find the A, right, or the X, or whichever you used. So we are going to find the area of the whole pentagon by 5 of these triangles, okay? So if you made any mistakes, guys, let's go fix that. Let's move on to part B. You can pause at any time, of course. Part B says to find the lateral area. We're finding the lateral area for the solid. Okay, ladies and gentlemen, the lateral area will be found using the formula LA equals PH. The perimeter of the base is 55. The height of the prism is 40. Therefore, our lateral area is going to be 2,200 yards squared. All right, next question, part C. Find the surface area of the solid. Okay, our surface area for part C is going to be roughly 2,805.60 yards squared. Just so you're clear, 2,200 was our lateral area, and one base area was 302.80, so we're going to use 2 of those since the prism has 2 bases. Finally, let's zoom out and see where we're at right now. Let's go to part D and find the volume of the prism. Finally, our volume is roughly 12,112 cubic yards. The formula we should have used is V equals capital BH, right? So that's the area of the base, or 302.80, times the height of the prism, which is 40. Thus, it gives us our volume. Question 4. The Campbell's soup can on the right is a right cylinder, and the diameter of each base is 8 centimeters, while the height of the can is 12 centimeters. Leave all answers below in exact form in terms of pi when possible. Okay, so here we go. Part A, it says to completely label the net at the right. So I'm going to kind of combine a few steps here. So first of all, they told me the diameter of each base is 8. So what I'm going to do is I'm going to draw a diameter. I'm going to label it 8, right? These are centimeters. And then I'm going to have the radius up here, which is also 4. The height of the can is 12 centimeters. So not only is it here, but it's also going to go here. So that's 12, that's 12. My question to you is, what is the length of the rectangle? The length of the rectangle is going to be 8 pi, because when we talked in class, we said that the top of the rectangle for all prisms and cylinders was once wrapped around the base, right? So the perimeter of the base, or in this case, the circumference of the circle, is the same as the top of the rectangle. All right, now we're ready to get going for the next part. So we have our net, we have our things labeled. Maybe what I'll do is I'll make a little checklist, right? Maybe I'll see the radius is 4, the diameter is 8. Maybe we'll go circumference is 8 pi. Okay, so that's what we know so far. Part B, the marketing department, right? So the marketing people at Campbell's, they want to know how much space is available for the label to wrap around. How many square centimeters are available for the label space? The label space for the Campbell's soup can is only going to be the lateral area. All right, guys? So if you just take a look at our diagram, or honestly, just think with some common sense, the label of any can is wrapped around the lateral surface, right? There's no label on the top, there's no label on the bottom, right? The top and bottom and the walls are actually aluminum, which brings us to our next question. In exact square centimeters, how much aluminum would be used to make the can? So once again, ladies and gentlemen, the can is going to have a top, a bottom, and the surrounding surface. The amount of aluminum that would be used to make one can is going to be exactly 128 pi centimeters cubed. Centimeters squared, right? Square centimeters. So guys, the can part, right? The surrounding surface, the lateral area, we've already done. That's 96 from the previous question. And then you're going to have two base areas that are each 16 pi, which makes a total of 128 pi square centimeters for the aluminum. Part D, what is the amount of soup that can fit inside or in the can in cubic centimeters? The amount of soup that can fit inside the can will be its volume, right? We're talking about the cubic space, the cubic centimeters that fit inside. So the formula we should have used is pi r squared times h, or we could have used capital BH, right? Area of one base is 16 pi multiplied by 12 high, right? 192 pi cubic centimeters. All right, ladies and gentlemen, this brings us to our last question, question number 5. A box of the famous Toblerone chocolates. Guys, if you've never had Toblerone's chocolates, I highly recommend. But anyway, they come in this cool box, all right? So it says the box of the chocolates is a regular, right, triangular prism. If each base has a perimeter of 9 centimeters and a lateral edge is 12 centimeters long, then provide the information below. We are going to leave our answers in exact form, no decimals. So let's start off by labeling the net, okay? So I'd like to start off by asking you, what is this length right here? That length will be 12 centimeters long, and as a matter of fact, I'm going to carry that 12 all the way down throughout the net. What do the lateral edges also represent on this solid? The lateral edges, guys, don't forget, are also going to represent the height. So the height of this box, as if you stood it up on the triangles, is going to be 12 centimeters. All right, the perimeter of the base, they told us the perimeter of the base is 9. I'm jotting that down as well. Right, so the perimeter of the base, or bases, each base is 9 centimeters. So let's head over here. We're going to label this with 3, 3, and I'm going to hold off on this 3. Well, I guess I could put it now. Okay, but that's 3. And then we're going to have 3 here as well, and 3 here as well, right? So we're going to end up with equilateral triangles because they mentioned the bases were regular. So now I'm just going to follow along with my 3s, and then this is also 3. Okay. So ladies and gentlemen, here's what we're going to do next, all right? I think we've labeled the net except for one very important part, okay? So I'm going to zoom in here, and I'm going to draw the height of this base, right? Maybe I'll also draw it over here as well. Okay. So what I'd like to know from you now is this. What is the exact length of that question mark? All right, that's going to be the height of the triangle, the height of the base. So I'd like you to leave your answers in exact simplified form. The length of that question mark, which is also the height of the triangle, is going to be 3 radical 3 over 2. All right, guys, we got to use our 30, 60, 90 rules, which I just have written down very quickly over here. So I'm going to match that up with the general rule and then our specific example here. Okay, so that height is going to be 3 radical 3 over 2. All right, so now it says how much, part B, here we go, we're down to our last 2 questions. How much cardboard is needed to produce 1 box of Toblerone's chocolate? Ladies and gentlemen, I know we were asked to try to keep this exact for a little while, but if you read the directions and you saw the multiple choices, I do think it's a little bit more beneficial to write this. It just gets very messy, gets very sloppy. So we're changing up the directions a little bit. So instead of being exact, they're asking for approximate. So here, in order to get there first, we are going to need the area of one base. So one base is an equilateral triangle, right? So we would use 1/2 times 3 times 3 radical 3 over 2. So the area of one base is roughly really about 3.9, right? 3.897. So now let's go ahead. And now for the box of chocolate, excuse me, we only need the outside cardboard. So that's going to be your surface area. So I'm going to use LA plus 2 capital B's, but I'm using LA is the perimeter of the base times the height. 9 times 12, which is 108, is my lateral area. That's the area besides the 2 triangles. Now, I'm going to take one triangle and double it, and then the total is going to be the amount of box space we need in cardboard. All right, finally, we're going to try to find exactly how much space is there inside of each box of Toblerone's chocolate. Now, what I'm going to do here is, guys, I'm also going to say, let's see if we could do this. Let's keep it exact this time. I'd like you to use the area of one base is 9 radical 3 over 4. Okay, and that's found by using this calculation here. But what I'd like you to do is please find the exact volume of how much space there is inside each box of Toblerone's chocolate. The volume or the exact space of the inside of the box is going to be 27 radical 3 cubic centimeters. All right, so what we're going to do here is take that exact base area, all right, capital BH, and multiply it by 12 centimeters tall. So if you put your 12 over 1 and multiply, we end up with 108 radical 3 over 4, or 27 radical 3 in simplest form. All right, so ladies and gentlemen, we've completed our 5 questions. Now, here is something to remember. You should have been answering the questions on here as we've gone along. Each of those will get you a certain number of points. And the work that you must submit, let's do that right now. So if you were using your iPad, you should save your progress and go submit that on Google Classroom. If you are using paper versions of this quiz, then you're going to have to take a picture of each of the pages. All right. I think, in my opinion, you probably should have used your iPad because you can use, your highlighters and stuff like that. So, ladies and gentlemen, you will be graded for this quiz on how well you answered the questions on the Edpuzzle, as well as posting your work in handwritten form. All right, guys. Thank you very much. There's no homework for the weekend. I will see you guys next time.